Hello to everyone. In this video, let us discuss complex compounds. So in the first video of this lesson, what are the topics? Let us discuss here. First, what are the complex compounds and types of them, and the important terms present in a complex compound. So first, let us discuss regarding which one? Double salt. Double salt means what here? It is the addition of two different salts. And one more important thing here, when dissolved in water, a double salt loses its identity, and that aqueous solution of a double salt will give the positive test for all ions present in it. What are the examples? Let us see here. First one is carnallite, KCl MgCl26H2O. When dissolved in water, this split into K plus, Cl minus, Mg plus 2 ions. That means it is losing its identity, and that aqueous solution will give positive test for all the ions. That means K plus, Cl minus, Mg plus 2 ions. So this is one example of which one? Double salt, carnallite. Another one, Morse salt. What is its formula here? NH4 taken twice SO4, FeSO4 24H2O. It is another example of which one? Double salt. Name of this one is Morse salt. And another one, potash alum. What is the formula of potash alum? K2SO4 Al2SO4 taken thrice 24H2O. So these are some examples of which one? Double salts. So they give positive test for all ions present in them. Then come to complex compounds. So complex compounds also formed by the addition of two different salts, but when dissolved in water, they do not lose their identity. And another thing, they do not give positive test for all the ions present in them. So let us see one example here. Potassium ferrocyanide, K4FeCN taken 6. So this is an example of complex compound. When dissolved in water, this will give 4 K plus ions, and this total sphere exists as a single ion. So Cn say taken 6 minus 4. So that means it is still retaining its identity in aqueous solutions. And here actually this potassium ferrocyanide is having K plus, Fe plus 2, Cn minus ions. But its aqueous solution does not give positive test for Fe plus 2 and Cn minus ions, because they are not dissociated here. So that means here this is not giving positive test for all the ions present in it. So now this is an example of which one? Complex compound. Okay, then now the important terms let us discuss present in which one? Complex compound. What are the important terms? See here. This outside the square bracket, either left side or right side, this is called ionization sphere. What is this? Ionization sphere. And this square bracket, this place is known as up to here coordination. That means in this square bracket, that sphere is called coordination sphere. This is which one? Means coordination sphere. And here this iron is said to be central metal ion. Iron is central metal ion. And this cyanide is said to be ligand, or we can call that as a ligand. So these are the terms present in which one? Complex compound. ionization sphere, coordination sphere, central metal ion, and here the cyanide is said to be ligand. So these are the different terms. Now one more important thing here, iron belongs to which one? Transition family, that is a transition metal. Especially transition metals only form which one? Complex compounds. What are the reasons for the more, that means formation of complex compounds, moreover by which one here? The transition metals. So some reasons are here. First one is all transition metals are having which one? Smaller atomic size, high nuclear charge, and they have vacant d orbitals. So due to these three reasons, transition metal atoms will form readily which one? Means complex compounds by losing required number of electrons. Okay, then now let us see the types of complex compounds. So based on that ligands, based on the type of ligands, two types of complex compounds are present. What are the first one and second one? Let us see here. First one is homoleptic complex compounds. Homoleptic means what here? The complex compounds having only one type of ligands are said to be homoleptic. That means already we observed one example, K4FeCN taken 6. Only one type of, that is cyanide, only one type of ligands are present in it. So it is known as homoleptic complex compound. And the second one is here heteroleptic. Heteroleptic means what here? The complex compound which contain different type of ligands. So see here, chromium is central metal atom or ion, and NH3 is one type of ligand, chlorine is another type of ligand. So now it is having two different type of ligands, so known as heteroleptic complex compound. Now this is one type of classification, and another type of classification also there. What is that? Cationic, anionic, and neutral complex compounds. If coordination pair having no charge, that is said to be neutral complex compound. So example for us, COCN taken 6. Here this coordination pair having no charge, so it is said to be which one? Neutral complex compound. And if the coordination pair is having negative charge, that is said to be anionic complex compound. So example is here K4FeCN taken 6. If we remove these 4 K plus ions, we might see the formation of -4 here. That means this coordination pair getting negative charge. So now this is said to be anionic complex compound. And if coordination pair getting positive charge, it is said to be that means which one? Cationic. This is anionic. And if that coordination pair is getting positive charge, that is said to be cationic. So one example here, CrNH3 taken 5 Cl2Cl. If Cl minus ion is gone away, now we can get a positive charge on this coordination pair. So this is now called positive coordination complex or positive complex compound. This is negative complex compound, that means anionic complex compound. This is cationic complex compound. This is neutral complex compound. So these are the different types of which one? Complex compounds. Now let us see the ligands. What is meant by ligand and classification of ligands. So now first let us define the ligand. What is ligand? A cation or anion or neutral molecule which can donate lone pair of electron to central metal ion to form coordinate covalent bond. That is said to be which one? Ligand. So the species which ready to donate lone pair of electrons to central metal ion and can form coordinate covalent bond. That is said to be which one? Ligand. Okay, first we should know the naming of ligands. How to name the ligand? For example, if ligand is having which one? That negatively charged ligands. These are, that means which one? O suffix is added to the name of the ligand. O suffix is added to the name of the ligand. That means if Cl minus ligand is there, it is named as chloro. Br minus ligand, bromo. I minus, iodo. Cn minus, cyano. So O suffix is added to the name of the negatively charged ligands. And also come to positive charged ligands. IUM suffix is added to the name of the positively charged ligands. For example, NO2 plus, it is known as which one? Nitronium. So like that. And another one, NH2 NH3 plus, this is named as hydrazinium. IUM suffix should be added to positively charged ligands. Okay, then come to the classification of ligands. What is the classification on based on which one? Means based on the charge present on the ligand and also based on the number of donor atoms present in a ligand. We have the classification of ligands. So in that the first one is which one here? Unidentate neutral ligands. Unidentate neutral ligands means what here? They have no charge, they are uncharged and they have only one donor atom. Such type of ligands come under this one. Example here so many are there. First one is NH3 amine and H2O aqua and O2 dioxygen. O2 is which one? Nothing but dioxygen. CO means carbonyl. NO nitrosyl. NO is which one? Nitrosyl. And PH3, which one here? PPH3 also you can consider here. Triphenyl phosphine and PH3 phosphine. So these are some examples of which one? Unidentate neutral ligands. That means they are having only one donor center or only one donor atom and having no charge. Okay, then after that unidentate anions. Anions means having negative charge. So unidentate or monodentate also we can call them. Unidentate anions. So examples are which one? F minus. This is named as fluorido or we can call it as fluoro. Cl minus, same chlorido or chloro. Br minus bromo. I minus iodo. Cn minus cyano. Cn minus named as cyano. So these are some examples and you can go for which one? O minus 2 oxido. This is also come under unidentate anionic type of ligand. Okay, after this, which one here? Unidentate cationic type of ligands. Unidentate or monodentate cations. So these are having which charge means positive charge. So what are the examples for that? NO plus known as nitrosonium and NO2 plus nitronium and NH2 NH3 plus hydrazinium. So these are examples of which one? Unidentate cationic type of ligands. Okay, then come to the bidentate ligands. Examples of bidentate. Bidentate means what here? They contain two donor atoms. They contain which one? Two donor atoms. Example in that first, ethylene diamine. Ethylene diamine formula NH2 CH2 CH2 NH2. Simple representation En. Here this nitrogen are donor atoms in ethylene diamine. This is an example of bidentate ligand. And also another one here, oxalate, COO minus, COO minus. Now this can donate lone pair of electron to M. So now oxalate ion come under bidentate. Another one, glycinato. Glycinato formula NH2 CH2 COO minus. This can donate and this also can donate one lone pair to central metal ion. So glycinato, ethylene diamine, and another one here oxalato, propylene diamine. Propylene diamine formula we can write like this: NH2 CH CH2 CH2 NH2. So propylene diamine also come under which one? Bidentate ligand. Okay, then we have to see which one? Polydentate ligands. Polydentate means what here? They are having more than two donor atoms in that to form dative bond. Now let us see some examples here. What is the first one? Diene. What is the full name of diene? Diethylene triamine. So diene full name diethylene triamine. So we can write the structure like this: NH2 CH2 CH2 NH CH2 CH2 NH2. 1 2 3. Three donor atoms are present in this. So diene come under polydentate ligand. Okay, then after that another one is there, pentadentate ligand. What is that pentadentate ligand? Example, ethylene diamine triacetate, EDTA minus 3. Ethylene diamine triacetate. This is ethylene diamine means two nitrogens and write one hydrogen here. Here we have to write CH3COO minus, CH3COO minus, CH3COO minus. 1 2 3 4 5. So it is having 5 donor atoms. So this is come under which one? An example of pentadentate ligand. And another one, hexadentate ligand, EDTA minus 4. That means this hydrogen also replaced with CH2COO minus. So here it is having 6 donor atoms. So this is an example of which one? Hexadentate ligand. Okay, these are examples of polydentate ligands. Now let us go for another type of ligand, ambidentate ligand. What is the meaning of ambidentate ligand? Here see, Ambidentate ligand contain more than one different type of donor atoms. More than one different type of donor atoms, but at the time of coordination, only one of the donor atoms coordinate with the central metal ion. So now here examples for that: cyanide, Cn minus, and this can be written as Nc minus, isocyanide, and then SCN, that means thiocyanate S, and another one NCS, thiocyanate N. So at the time of coordination, either S or N, any one of them will coordinate with central metal ion, but not the both of the donor atoms. So such a type of ligands which contain more than one donor atoms, known as which one means here ambidentate ligands. Okay, then after this let us see which one: effective atomic number. What is effective atomic number? See here. Effective atomic number means the resultant number of electrons present with central metal ion after formation of the complex compound. That is known as which one? Effective atomic number. So the resultant electrons present with the central metal atom after the formation of a complex compound. So how to determine effective atomic number? See here. Formula to calculate effective atomic number: atomic number minus oxidation number plus 2 into number of dative bonds formed by the ligands. So this is the formula to calculate effective atomic number. What is the use of this effective atomic number? If the calculated effective atomic number is equal to atomic number of any one of the inert gases, now we can say that complex compound is stable. Otherwise, that is unstable. So now let us go for one example. K4FeCN taken 6. Here we have to calculate effective atomic number of iron. Before that, let us calculate oxidation number of iron. As 4 potassium atoms here, 4 into plus 1 plus iron X plus 6 into minus 1, each cyanide minus 1, equal to no charge on the complex, so 0. Now we can get X equal to plus 2. That means oxidation number of iron is how much? Means plus 2. So now atomic number 26, oxidation number plus 2, so 26 minus 2 plus 2 into each cyanide form only one dative bond because it is a bidentate ligand. Sorry, it is a monodentate ligand. So each cyanide form only one dative bond. So now total 6 cyanides means 6 dative bonds. We get 24 plus 12, 36. And this 36 is equal to which one? Atomic number of krypton. So that means helium, neon, argon, krypton. So krypton atomic number 36. So this complex compound is now stable. Now let us see another example in which a bidentate ligand is present. Example here, K4Fe C2O4 taken thrice. So now here C2O4 is having minus 2 charge. So let us calculate oxidation number of iron. 4 potassium means plus 4 plus X minus 6 equal to 0. X equal to, again here we can get to plus 2. Now effective atomic number equals to 26 minus 2 plus 2 into each oxalate form 2 dative bonds. So now here, now what we have to write here? 3 oxalate ions are present. Means total number of dative bonds how many? 6. because we have to write 2 into number of dative bonds. So now here we can get which one, 2 into 6. So here we can get again 36. So this is also stable. Okay, right. Bye.